Hello, our project is SWITTers, separating driver classes to estimate the safety benefits of AI-corrected and AI autonomous vehicles. My name is Nolan Olada, and I'm joined by Micah Zimmerman and Nathan Palmer. Our project focuses on identifying high-risk driver classes so that we can estimate ways AI driving systems can help make the road safer. We aim to use various classification methods to determine the most dangerous conditions associated with collisions and to find hidden relationships in our dataset in order to further our understanding of them. Our database is compiled from the Statewide Integrated Traffic Record System, or SWITTers for short. It contains data from almost 10 million collisions in California from 2001 to 2020. It exists in the form of an SQLite file that is almost 10 gigabytes in size and consists of dozens of attributes.
Hello, everyone. My name is Micah Zimmerman. Thank you, Nolan, for starting us off. The first step in our data extraction and pre-processing was to download the compressed SWITTers source file to our local computers and connect to it in our Python script using an SQLite 3 connection object. We were then able to disable the journaling mode to reduce the memory considerations of excess journaling, and we're able to drop in uninteresting columns using an SQLite cursor as well. The random sample frames were generated using a 10,000 sample draw composed in an SQL dialect query. The case IDs were extracted into a list and used to pull in matching records from the victims and parties tables of the SQL file. Our code base also presents the option for a mutually exclusive repeat sampling event to pull in data objects that do not match the existing frames.
Much cleaning had to be done before we could work with the data. Much time and effort was put into deciding on which attributes to drop to reduce dimensionality, normalizing and encoding values, as well as dealing with null values. We found that the database is considerably prone to human error, containing many attributes with staggering amounts of null values, as well as some with very poor encoding. Our data cleaning efforts did a lot to help, but there'd be much more work to do in order to make the database perfectly clean.
Our numerical principal component analysis, or PCA, was conducted using a big O n-squared algorithm that performs an exhaustive cross comparison of all attribute columns that were converted or identified as numeric in the previous data examination rounds. The algorithm that you see before you produces a 992 cross-plot figure in the form of a PDF file that can be examined as part of our repo structure.
Our principal component analysis for the categorical attributes in the dataset consisted of first extracting all the categorical variables from the dataset, then running chi-squared tests on all the pairs of attributes in order to find relationships with the strongest associations. These relationships were then saved to a separate file for easier viewing, where you could manually filter attributes to further reduce dimensionality of our data.
Hello, and I'm Nathan Palmer. We use data cubes to identify certain trends. A data cube refers to a multi-dimensional representation of data that allows for the exploration of information across different facets or dimensions. In essence, it organizes the data in a manner that can be visualized as a cube-like structure, with each dimension representing a specific aspect of the data. It's similar to the concept of pivot tables, particularly in its ability to rotate through various dimensions to view data from different perspectives. With that information, we were able to identify specific trends, like inexperienced drivers are responsible for most accidents and collisions in California. Weather conditions, mostly like rainy conditions, are responsible for an increased accident rates, significantly for inexperienced drivers, but it also reflected on experienced drivers as well. Pedestrian accidents also mostly occurred at night in urban settings. However, fatality rates were higher at night during the day. We also were verifying trends with classification models such as decision tree classification, FP tree-based classification, and Bayesian belief network classification.
The decision tree classification with sklearn library was a resounding success with using the attributes that were identified as interesting during numerical PCA. The interested viewer is encouraged to try these tools for his or herself by exploring the data, the code, in our repository folders.
Another classification method we used were frequent pattern trees. Using some helpful Python libraries, we were able to find frequent patterns of attribute values that were associated with a given rule.
Bayesian belief networks are probabilistic relationships among a set of variables. Nodes in the graph represent variables, while edges represent conditional dependencies, and each node has an associated conditional probability distribution, which quantifies the likelihood of its given state of its parent nodes, allowing the probabilistic interface and reasoning under uncertainty. We were able to identify with this noted patterns with age among fatal accidents as well as experience. So men under the age of 30 were responsible for a lot more accidents on average. Also, inclement weather increases the rate of fatal accidents across the board.
Some of the key findings our group was able to uncover from the Switter's dataset were the trends in experienced and solo drivers. Both of these driver classes, although oftentimes observed separately, experience fall into a higher risk category concerning collisions, at least in the state of California. This solo and inexperienced driver trend would appear to suggest that AI co-pilot systems are a desirable feature in AI vehicles. Some of the proposed future works that we have in mind for this project, including integrating data from alternative sources such as AI vision systems, autopsy reports, or weather monitoring systems. We would also be interested in performing a rigorous numerical PCA on the interjoin between collisions and victims tables to examine more information about the victims of collisions.
For more information, please check out our GitHub repository, and you can see the full project there. Thank you very much.
Thank you.